In this video, we will take the derivative of the function f of t equals sine of the square root of 2 to the t plus 1. In order to take this derivative, it is useful to remember that you cannot have a trigonometric function such as sine or cosine without having something inside of it. What is inside this sine function is, of course, this square root and what is underneath it. So even though they're not written here, we can imagine that there is a set of parentheses indicating this to be the case. As for taking the derivative of this function, well, we can see that what this sine function has inside of it is more complicated than the plain variable t, and therefore it makes sense that we would have to use the chain rule in this case because we're dealing with a composition of functions. In terms of using the chain rule, a good choice for you, our substitution, would be to set the entire thing inside our blue set of parentheses here equal to u. Now, the reason why we do this is because once we do, our original function with u inside of it instead becomes sine of u, which is something that we can use our basic derivative rule for sine on. So the derivative of our original function becomes the derivative of sine of u times u prime, as the chain rule tells us. The derivative of sine of u is cosine of u, and then we're still multiplying by u prime. And what we have here is cosine of, well, u was the square root of 2 to the t plus 1. So here is the square root of 2 to the t plus 1 inside of there. And then we're still multiplying by u prime, which is the derivative of the square root of 2 to the t plus 1. And we are more or less halfway there at this stage. However, when we go to take the derivative of the square root of t to the t plus 1, we're going to have to employ the chain rule a second time. Why? Well, if we look at this particular function, we can see that underneath the square root, what we have is more involved than just the plain variable t. It's a more complicated function than that, and so we have yet another composition. For this particular chain rule, a good choice for u would be what is under the square root. We can let it be 2 to the t plus 1, and we can proceed from there to be able to take our derivative. In this case, we would have that our original function with u plugged into it is, of course, the square root of u, or u to the 1/2, and then we can proceed from there, taking what our derivative should be. I'm going to carry on at this stage. We had cosine of the square root of 2 to the t plus 1, and that's being multiplied by the derivative of this square root function. We rewrote this square root function as u to the 1/2 for this choice of u. So via the chain rule, we know that the derivative should be the derivative of u to the 1/2 times the derivative of u. The derivative of u to the 1/2 is 1/2 u to the minus 1/2 via the power rule. And then we're still multiplying by the derivative of this u. So I'm going to copy down what we have so far. There's the cosine of the square root of 2 to the t plus 1 times 1/2. All right. We know that our u right now is 2 to the t plus 1. I'm going to replace that in here. So I have 2 to the t plus 1 raised to the minus 1/2 power. And this is getting multiplied by u prime. So the derivative of 2 to the t plus 1. And we are very nearly done. To wrap up our second chain rule, we at long last need to take the derivative of this function. So I'll copy down the beginning of this as is, the cosine of the square root of 2 to the t plus 1 times 1/2 times 2 to the t plus 1 to the negative 1/2 times, here we go on taking this derivative. The derivative of 2 to the t is one of our basic rules. It is ln of 2 times 2 to the t. And we will add to that the derivative of 1, And the derivative of 1, when you add or subtract a constant, the derivative of a constant becomes 0. So I don't necessarily need to write that. But at this stage, we have taken our derivative. In terms of simplifying, of course, we didn't need to write this plus 0 on the end. We could instead leave that off, and we could simplify this by writing it. Well, you're able to multiply in any order, and we usually put constants out front. ln of 2 is a constant. And so I could write this as ln of 2 times 2 to the t times cosine of the square root of 2 to the t plus 1. Entire thing divided by this 2 that was already in the denominator. And then we have 2 to the t plus 1 to the negative 1/2. That gets moved downstairs with an exponent of positive 1/2. But an exponent of 1/2 means you're dealing with a square root. So this would be the square root of 2 to the t plus 1. That's a little messy, but here is our final answer, simplified. And we are done.